Let's see if it'll let me record this. All right, can you guys still see the screen? Because mine just,
Yeah.
okay. So you can still see the problem. All right, cool. So I'll give you a minute to figure this out. Yes, Brianna, I got your answer correct. Yay, I got one.
Oh, you can.
Did anybody else get the answer? All right. Well, you know, I always look at everything the same because if I ever get confused or I'm feeling overwhelmed in a question, I always go back to my basics and I make sure I just start from the beginning. So I'm looking at my order. You know, I always start with my order and I see the order is for Humulin R 15 units. I'm mixing with Humulin N 15 units and Humulin R 8 units before meals with coverage. So there's one part of my order. Then there's a second part of my order, and that is the finger stick coverage. So no matter what, I have to give the 15 units and the 8 units. We know that. So now I have to go in and take my patient's finger stick, and I get a finger stick of 302. So that's when I go to my coverage order, and I find where 302 falls, and it falls right between 301 and 350. And that says between 301 and 350, the patient should get additional 6 units. So the question asks, what is the total amount of insulin the patient will receive before breakfast? Finger stick was done before breakfast. And the answer is, Brianna? Jackie, Aaron, what's the answer?
29.
29 units. And make sure you spell it out. 29 units. And that's exactly what it asked you. So you all took the 226 exam, right? That's what you're going to take?
Yes.
All right. So that's one type of question you may come across. So here's another type that you may come across. So I'm going to give you a minute to solve. And you can, again, type it into the chat. All right. So this is asking you, this is a feeding question. So you have to read your questions to know what it's asking you before you start overthinking everything, as nursing students tend to do. So the order says ensures 50% strength tube feeding, and it's already running at 20 milliliters an hour. All right, but what is the question asking you? This is a lot of nice information. It's telling you what it is, what the order percentage is. It's telling you what it's running at. Okay, great. But the question is asking you how many milliliters of water will the nurse add to a 4-ounce can of formula? So you probably initially paused and said, oh my gosh, I got to use the 20 milliliters an hour. Am I doing an infusion rate? But that's not what the question is asking you. So the question is asking you, how much water will you add to a 4-ounce can in milliliters? So we have a 4-ounce can. I'm bringing you back old school. I'm solving for milliliters. How do I get rid of ounces and get to milliliters? Well, I know 1 ounce is 30 milliliters. Gets rid of my ounces, and that means 4 times 30 is 120 milliliters will be added to that 4-ounce can to make 50% strength. Yay! Got that? You guys feel good about those? Excellent.
Just a quick question. The 50% then wasn't really needed?
No, not at all. It's just telling you the doctor ordered 50% strength or half strength. He needed you to dilute this 4-ounce can of formula. So he needed you to dilute this formula to make it half strength, 50% strength. So how do I dilute 4 ounces to make it 50% strength? Well, I add the same amount in water, 4 ounces of water. So this is your formula, and this is your water. So you'd get probably a bigger bag and pour both into one giant bag. And that total bag is 8 ounces. But we don't do our intake and output and anything in ounces. And the question said milliliters. So it says, how much water will you add? Well, I'm going to add 4 ounces of water. So 4 ounces times 30 milliliters, because you do your dimensional analysis, is 120 milliliters of water.
Got it. Thank you.
All right, cool. So we're always looking for that given, and that's our doctor's order. But this tells you order 5 milligrams per kilogram. That's a 2-factor order. I have a patient's weight. How many scored tablets with a single scored line should the nurse prepare? So my wanted, it's telling me, is how many tablets? How many tablets should the nurse prepare if the medication is labeled 250 milligrams per tablet? So I start with my order, 5 milligrams over kilogram. That's 2-factor. He wants that meds given based on the patient's weight. No problem. So I've used that. So I need tablet and I have milligram in my numerator. So what can I use in my problem? Well, I can use what's the actual label of the package is, what the tablet is. 250 milligrams per tablet. That gets rid of my milligrams and it gives me my tablet in my numerator. But now I have to get rid of this kilogram. So I've used this. The only thing left is the patient's weight, but it's in pounds. So I need a conversion. 1 kilogram is 2.2 pounds. I cross off my kilograms. How do I get rid of pounds? I use the patient's weight. So it's 165 pounds over 1. And now I am done. Everything that is not wanted is eliminated and I'm left with tablets. So now it's just math. So 5 times 165 is 825 and 250 times 2.2 is 550. When I divide 550 into 825, it will give me 1.5 tablets. And that's possible because it's a single scored line. Basically, it's a tablet with a single scored line. All right, everybody, you got that?
Yep.
Awesome. All right. I would like you to do this one. All right. So I'm going to read my question as I always do. I'm going to highlight things that I am going to need. So IV is labeled. So the IV has a label on it that it has 60 milligrams per 2 mLs, and it's infusing at 60 drops a minute. All right. How many micrograms per minute is the patient receiving if they weigh 120 pounds using a micro drip? So you have to know micro drip is 60 drops per minute. All right. I mean milliliter, sorry. I'm doing my own thing now. 60 drops per milliliter. It means it takes 60 drops to make 1 whole milliliter. All right, so I got my information. So it doesn't matter if you start with the given or the wanted, but I know what's wanted. It's telling me it needs to know how many milligrams per kilogram per minute. It's a 3-factor solve. You have to solve for 3 factors. So I know I'm solving for that. So where do I start? Well, it's asking me a very specific question about rate and time. So I always look for things like volume and time. So if I'm looking in my question, volume with anything with time in it is minutes. There's no hours or anything in here, but this has time in it. And I need time in my denominator. So I'm going to start with 60 drops per minute. And that's awesome. So now I've already got one part of my equation solved. So then I think, all right, how do I get milligrams and get rid of drops? Well, what else is in my problem? Well, I can use my micro drip to get rid of drops. So 60 drops in every milliliter. Cool. But I still now have to get rid of milliliter and get to milligrams. So I look to my problem. Is there anything offered? And there is. 60 milligrams in 2 milliliter. Beautiful. And now I got rid of milliliters. My drops are gone. Now I have milligrams. Excellent. But I'm not done because my problem also wants kilogram. But my patient's weight is in pounds. I've used everything else in my problem. Okay, so how do I get kilograms in this problem? Well, I'm just going to put it there. 1 kilogram is 2.2 pounds. Okay. So now I have to get, so I have kilograms now. Now I have to get rid of pounds. What can I use? The only thing left, 120 pounds. And I put that, I'll put a 1 over it. Now I know what you're thinking. We're breaking all the laws of math and everything like that, but that's okay. We're nurses. We're doing things the way we want to. And this is the way we have to solve it. So once you have everything crossed off you don't need, and you only have what you do, which is milligrams per kilogram per minute, now it's just math. So then you do the math across the top. And believe it or not, it's like 132. If you cross off your zeros and 60s, I like to cross off like numbers. So 132 over 240. And when you divide that, it's 0.55 milligrams per kilogram per minute. Boom. All right. Try this one. All right, let's do it. Let's get crazy and do this one. All right. So it's telling you a lot of information. D5W IV to infuse at 50 milliliters an hour. Great. But at 9 a.m., you walk in the room and there's only 125 milliliters in the bag. Left in the bag, remains in the bag, in the bag. So we're starting with that, 125 milliliters. All right. So when I read this, I continue to find out that it has a drop factor of 20 drops per milliliter. But it's also asking me what time will the IV finish infusing. So we always start with left in the bag and we solve for time, and time is hours. Hour has to end up in the numerator, okay? Hour. So when I look at my problem, I've used my solution and I have to solve for hours. So when I look in this question, the only thing with time in it is this. This has no time in it. It's just telling me drops per milliliters. Tell me what drops factor the tubing has. So I need to use something with time. So how do I get rid of milliliters and get to hour? I use 50 milliliters an hour. And that, my friends, is it. You do the math. So 125 and then by 50. And then when I divide 50 into 125, it gives me 2.5. So remember, everything to the left of the decimal is hours, so that's 2 hours, and everything after is minutes, but there's no such thing as 0.5 minutes. So we take 0.5 and we multiply it by 60, and when we do, it gives us a beautiful equal 30 minutes. So it will take 2 hours and 30 minutes for 125 milliliters to infuse into the patient. But the question didn't ask me that how long it would take. It asked me what time it will finish. Well, Professor K walked in at 9 a.m., 0900, and if it takes 2 hours and 30 minutes to infuse, Professor K has to go back in there at 11:30 with a brand new bag to give to the patient. So that is the exact time in military time. That's how you write it. Don't you dare write this, because that means 11:30 a.m. in standard time. We are talking military time. That's it. Boom. Yay. So much fun. All right, let's do another. Well, I'll come back to that one. Let me get you into something different. All right, give this a try. All right, so they are starting with calculate milliliters an hour. So there's my wanted right up front. To set an IV pump for a continuous dose of heparin 800 units an hour, and the heparin is labeled 25,000 units and 250 milliliters. So we are going to be running something through an IV pump. So we're solving for milliliters an hour, plus it tells you milliliters an hour. Beautiful. All right, so I always start volume over time, or strength over time. So that's 800 units over an hour. Sorry. So I've used that. So I have hour. So how do I lose these units and get to milliliters? Well, I go back to my problem. So I can use 25,000 units. Now be very careful when you're writing out your units so you don't mix a U up with as a zero. I saw that on one of my tests this week. All right, so I cross off units. And I'm left with milliliters an hour. Milliliters in my numerator, hour in my denominator. That's it. I'm done. So now I can just solve. So 800, excuse me, times 250. Or you can cross off your zeros. 1, 2, 3, 1, 2, 3. So 8 times 25 is 200. And 25 times 1 is 25. And that will give me 8 milliliters an hour. Jackie, did you find out where you? There you go.
Yeah, I saw that I did I put like 8,000, I think, instead of 800.
Or you
Yeah.
mistook the unit, the U. I see that so many times. All right, cool. Let's go to the next one. All right. So the order is for vitamin B12. The doctor wants to give 1,000 micrograms intramuscularly. Okay. Pharmacy sends up a vial, and the vial has a label that says every 2 milliliters has 5.5 milligrams in it. How many milliliters will you give? Well, how many milliliters will you give? I need milliliters in the numerator. So what's my order? 1,000 micrograms. Okay. How do I get rid of micrograms and get milliliters? Well, this is in milligrams, so I need a conversion. So 1 milligram is 1,000 micrograms. That gets rid of my micrograms, and now I have milligrams. How do I get rid of the milligrams? I look to my problem. 0, oops, nope, not 0. 5.5 milligrams for every 2 mLs. That gets rid of my milligrams. And look at that. It leaves me with only milliliters. Everything else has been eliminated. So I can cross off my thousands, or I can keep them. So 1,000 times 2,000 is 2,000. And 1,000 times 5.5 is 5,500. I divide 5,500 into 2,000. It gives me 0.363636. But 1 to 10, I mean, less than 1, I round to the hundredths place, which is 2 places to the right of the decimal. So I look immediately to the right. It is not 5 or greater. So I do not round up. So my answer is 0.36 milliliters. Sound good? Aaron? Sound good? All right. All right. Jackie, you need more time, or are you good? All right, let's do it. All right, I'm looking for my order. Well, the doctor said you can give morphine 1 milligrams every 2 hours for pain if needed. So my order is for 1 milligram of morphine. Correct, Jackie. Good. So what's delivered to me is morphine, and the label says 2 milligrams per milliliter, and it's telling me how many milliliters are you going to give your patient for their pain of 8 to 10. All right, no problem, because the patient's pain level, we got it every 7 to 10. Great. So it's asking me to calculate for how many milliliters will I give my patient. So I'm solving for milliliters. I need that in my numerator. The order is for 1 milligram. I like to put it over 1. You don't have to, it's fine. So I'm solving for that. How do I get rid of milligrams and get to milliliters? I use my problem. For every 2, there's 2 milligrams in 1 ml. Gets rid of my milligrams. It leaves me with milliliters, exactly what I need. So now it's just math. So 1 times 1 is 1, and 2 times 1 is 2, and 2 divided into 1 is 0.5 milliliters. Beautiful. Okay, do this one for the crowds. All right. So the doctor ordered 80 milligrams of methylprednisone, 80 milligrams IV push. The pharmacy sends a vial that says 25 milligrams per ml. And it's asking you the wanted is milliliters. So it's telling you everything it wants. I love it. It's in the numerator. So I start with my given, which is my order, 80 milligrams over 1. How do I get rid of milligrams and get to milliliters? I use what's in my problem, 25 milligrams in 1 ml. No problem. Gets rid of my milligrams. Now I have milliliters. Now it's just math. 80 times 1 is 80, and 25 times 1 is 25. And that will give me exactly 3.2 milliliters. Don't forget 1 to 10. We always round to the tenths, but this one landed perfectly. Awesome. Now, if you wouldn't mind doing this one. All right, let's solve this. Cool. So the order is for Neupogen, 9 micrograms per kilogram subcutaneous every day. It's telling you to calculate how many micrograms you're going to give. So that's your wanted. They need to know how many micrograms of Neupogen will you give sub-Q to the patient, and he weighs 50 pounds. So cool. We know we're solving for micrograms. So I really encourage you to keep doing this same step by step. I do this stuff in my head constantly now that I teach it, but I always resort back to the same steps. It's just like muscle memory. All right. You just keep doing it over and over. It will help you to not forget how to set up your problems. All right. So we always start with the given, which is the doctor's order. And he says, give 9 micrograms per 9 micrograms per kilogram. So that's my 2-factor order. So I got a 2-factor order, 9 micrograms per kilogram. I need micrograms, so I have it. So what's the big deal, right? But I got to get rid of kilograms. So how do I get rid of kilograms when the weight's in pounds? Well, 1 kilogram is 2.2 pounds. Gets rid of my kilograms. And I get rid of pounds by using the patient's weight, 50 pounds over 1. Now I look at my problem. Everything has been eliminated except for what I need, which is my micrograms. So now it's just math. So when we do the math across the top, it's 450 and 2.2, and divided is 204.54. Greater than 10 and up, I round. Wait, let me say this again. 10 and over, I round to the whole number. So this is 10 and over for sure. So I look to the number to the immediate right. 5 and up, I round up. So the answer is 205 micrograms. Beautiful. All right, do this. That would help me. So let's do the solve for the video. So the doctor orders 0.9 grams of acetaminophen. All right, great. And it's available in 500 milligram capsules. So what should the nurse administer? Well, with this problem, it doesn't tell me exactly what my wanted is, but all that it's available is a capsule. That's what I would bring to the patient. So my solve for and my wanted is capsule. I need that in my numerator. So 0.9. And it comes in milligrams, so I need a conversion. So 1 gram is 1,000 milligrams. Beautiful. Gets rid of my grams. And I can get rid of my milligrams and get the capsules by using my problem. 500 milligrams in 1 capsule. Gorgeous. So now it's just math. So 0.9 times 1,000 is 900. And 1 times 500 is 500. When I divide 500 and 900, it will give me 1.8. So if we're following the rounding rules, yeah, that's right. But we're giving a capsule, and I can't bring in 1.8 capsules. So you have to decide either you're going to give 1 or 2 in this situation. And 0.8 is definitely closer to 2 than it is to 1. So the answer is 2 capsules. Beautiful. All right. Why don't you solve this one for me? All right, let's do it. All right, so the order is to run 25 milliliters an hour of half-strength Pulmicare. The patient has a G tube, a feeding tube. So order is to run it at 25 milliliters an hour, half-strength. Calculate the flow rate. So I'm solving rate and a flow rate. So I'm giving either a pump or a drop, right? For an administration set that delivers 8 drops a milliliter. So this one gets everybody confused because it's like, wait, if we're 25 milliliters an hour, does that mean that there's a pump? Well, it doesn't say through a pump. It's just the doctor ordered 25 milliliters an hour. And it's asking you the rate. It's giving you a drop factor, but it doesn't say they have a pump. So if there's no pump, we're always solving for drops per minute. All right. And this is where the classic nurses overthink instead of just reading the problem. And I do the same thing. So I need drops in my numerator, minute in my denominator. So where do I stop? I have time. I need a rate and I have time. So I always look for volume over time. So what in my problem is volume over time? Well, the only thing with time in it is 25 milliliters an hour. So I'm starting there. 25 milliliters an hour. So it doesn't matter which one you want to eliminate first. Let's get rid of hour and change that to minutes. Well, I know there's 1 hour and 60 minutes. So I get rid of my hours. So boom, I got minutes. So now how do I get rid of milliliter and get to drops? Well, I'm going to go to my question. So there's 8 drops per milliliter. 8 drops per 1 ml. And now that leaves me with drops. Drops in my numerator, minutes in my denominator. Now it's just math. So 25 times 8 times 1 is 200, and 60 times 1 or nothing is 60. And when you do the math and divide, it's 3.33. We cannot split a drop. So we round. So we have to round to the whole number when it's drops because we cannot split a drop. We cannot split a capsule. So 0.3 is not 3 and up or not 5 and up. So we keep it the same. So we are going to be administering 3 drops per minute to our patient. Beautiful. I'm going to, this one should look familiar, but a lot of times you're used to seeing intake and output questions asking you for everything. So you have to really read what your questions are asking you before you dive in and start solving because you're convinced you're going to run out of time. So I really encourage you to read your full questions to find out what exactly that they want. So in this question, what exactly do they want from you? Well, they want to know how many milliliters, and we always do intake and output, and we solve for milliliters because that's how we calculate intake and output. So how many milliliters would the nurse calculate as output for the last 8 hours? So it's not even asking me for intake. It's asking me for output. So I would look at my question and go, all right, what qualifies as output? So D5W, 150 milliliters an hour, that's going into the patient. A cup of ice, that's going in. They took water with their meds. Now the aide reports the patient urinary catheter. Okay, urine, yes. Emesis is vomit, yes. Wound drainage, yes, I'm counting it. This is how I approach these type of questions. You don't know what to do until you read what they want. All right, so as output, what is the patient's output over the last 8 hours? Right, 850 milliliters. That's exactly what it's asking you. So please be cautious when you read these type of questions. You've got to read the whole thing. All right, now complete this one. Believe it or not, when they deliver you a unit of packed red blood cells, one volume could be 300, one could be 350, one could be 320. So it would tell you. So that's why this question is telling you that there is 1 unit of packed red blood cells ordered, and in that unit is 340 milliliters, and you have to give that over 3.5 hours. So it's asking you to calculate the flow rate. So through a blood administration set that delivers drops per minute. So what's missing again in this question? There is no word of a pump. There's no word of a pump, but there is a drop factor. So I'm solving for drops per minute. So numerator and denominator, cool. So I know that I'm solving for drops per minute. So how do I get there? I look for something like volume over time because I have time. And here is my volume over time. There's 340 milliliters and I have to give it in 3.5 hours. Beautiful. So how do I get hours to minutes? I know that one. 1 hour is 60 minutes. Gorgeous. Now I have minutes. Now how do I get rid of milliliters and get to drops? Well, I go to my question. I haven't used 10 drops per milliliter. So I cross off my milliliters and that leaves me with drops. Beautiful. Now it's just math. So now I do math across the top, which is 3,400, and then 210, divide that in there, and it gives me 16.166, and it's greater than 10, and I need a whole number. So it's 16 drops per minute. Perfect. Good. Now do this one. All right, let's do it. So the question is, an IV of 1,000 milliliters is infusing at 55 milliliters an hour. It's labeled with 1 gram and 250 milliliters. And it's asking you how many milligrams an hour of this medication is a patient getting. So it's asking for milligram an hour. So I need milligram in my numerator, hour in my denominator. So where do I start with some of this? Well, I have time again. All right. So when I have time, I always look for that volume over time. And there it is. So 55 milliliters over an hour. So I've used that. I know what I'm looking for. And then I have a vial that gives me grams and 250 milliliters. Beautiful. Well, I have hour in my denominator. I'm good. So how do I get rid of milliliter? Well, I use what's in my problem. So there's 1 gram and 250 milliliters. Gorgeous. Not a problem. I cross it off. But it's asking for milligrams, and now I have grams. So I need my conversion. 1 gram is 1,000 milligrams. Boom. And that is it. So now it's just math. So 55 times 1,000 is 55 100, and then 250 times 1 is 250. When I divide that into each other, it will give me 220 milligrams an hour. Beautiful. All right, let's do this one. So the question is saying the patient is receiving an IV now that is running at 8 milliliters an hour. And in that IV, it has 10,000 units of heparin in 250 milliliters. They want to know how many units of heparin did the patient receive in 3 hours. But I have to solve first what they're getting currently. So always remember that volume over time. How many units an hour are they getting now? They're getting 8 milliliters an hour. And they want to know how many units. But they want to know how many 3 hours, but I'm going to solve for hour because I have hour. So 8 milliliters, 2 units, I use what's in my problem. There's 10,000 units and 250 milliliters. This is where you got to be careful with your zeros too, with your units. 10,000 units and 250 milliliters. This gets rid of my milliliters, and then it leaves me units over hour. So when I solve, it'll give me 80,000 over 250. It'll give me 320 units an hour, but they want to know over 3 hours. So I times that 320 times 3 will give me 960 units. Oops. Units in 3 hours. All right, so make sure you're reading these questions. Beautiful. Let's go to the next one. All right, let's do it. So the doctor ordered 1 gram of vancomycin mixed in 250 milliliters of normal saline. And they want that to infuse over 60 minutes. The drop factor is 15. Calculate the number of drops per minute. So you don't even have to know if there's a pump or not. It's telling you what to solve for, drops per minute. So we're going to do drops per minute. So I'm looking at a rate. So I'm looking for that volume over time, rate and time. So I have 1 gram in 200. No, I'm so sorry. I just had a brain freeze. I have to give 250 milliliters in 60 minutes, volume over time. So 250 milliliters over 60 minutes. All right, well, that gives me my minutes, but how do I get rid of milliliters and get to drops? Well, I've used these two, and the only thing with drops is my drop factor. So there are 15 drops per ml. That gets rid of my milliliters. Beautiful. And then when I do my math across, it's 60, and 250 times 15 is 3750. When I divide, it'll give me 62.5. Brianna, did you find your error yet? So I can't split a drop. So I have to round to the whole number. 5 and up, I round up. So the patient will be getting 63 drops per minute. All right. I'm going to have you do these. Yeah, sorry if you're getting dizzy. Do this one. All right. The doctor orders an IV of half normal saline, 1,000 milliliters to run over 6 hours. Calculate the drip rate using a drop factor of 8. So no pump, it's drops per minute. Beautiful. Volume over time. We're dealing with rate. So how do I get rid of hour? 1 hour is 60 minutes. I can cruise all day doing this. Now I have minute. How do I get rid of milliliters to drop? I have my drop factor. So 8 drops per milliliter gets rid of my milliliters, and I'm left with drops. Gorgeous. So 1,000 times 8 is 8,000, and 6 times 60 is 360. When I divide that into each other, it gives me 22.22. We can't split a drop. So 22 drops per minute. Beautiful. All right, do this one. All right, so read your question in full, and it's just asking the total of the fluid intake in 8 hours, total intake in 8 hours. So I got to find everything that counts as intake. Well, the IV is definitely intake, 40 milliliters an hour. At lunch, the patient drank a 3/4 glass of tea, 3/4 pint of prune juice. Oh, the poor thing. 1 cup of coffee, 1 cup of granola. Well, nope, that's food. And a half a glass of water with her meds. What's the total fluid intake in 8 hours? So let's start with the IV, 40 milliliters an hour. Well, I need 8 hours. So 240 times 8 is 320 milliliters. Boom, used it. All right, 3/4 glass of tea. Well, I like to go right to a decimal. So 3/4 into a decimal, just in case you forgot, is 4 divided into 3 will give you 0.75. So 0.75 times 1 glass is 240 milliliters. So you can do 1 glass. This was a glass, I'm sorry, 0.75 glass, and 1 glass is 240. So you do the whole dimensional analysis. So 0.75 times 240 is 180 milliliters. All right. So as I'm going through it, 3/4 pint. So 3/4 pint is 0.7 times 1 pint is 480. And that will give me 360 milliliters. 1 cup times 240 is 240. So 240 milliliters. So I'm just going through everything my patient drank, and a half a glass of water, half is 0.5 times 1 glass, 0.5 times 240, and that will give me 120 milliliters. So when I add it all up, you are both correct. The total is for 8 hours, 1220 milliliters intake. Beautiful. All right. So I'm going to pause this recording right here.